So this is your f of x, right? Which is defined as cos 2x minus a plus 2 cos x plus a plus 1 upon sin x. And one limit is also given. So let's simplify this function f of x first. We know that 1 plus cos 2x is 2 cos square x. So we will have the rest part a plus 2 cos x and plus a, and this whole divided by sin x. Or you can write this as 2 cos square x minus a cos x plus a and minus 2 cos x, which is divided by sin x. Now if you take 2 cos x common from here, so we are getting cos x minus 1, this is one part, and if I take minus a common, it gives you cos x minus 1. Okay, now can you write this expression as 2 cos x minus a, and this is multiplied by cos x minus 1 divided by sin x, or even you can write this as 1 minus cos x into a minus 2 cos x divided by sin x. So this is your f of x. Okay, now let's use that limit concept. So we have limit x tends to 0 f of x upon x as half. Okay, so we have this f of x. So what about this limit? It will be 1 minus cos x multiplied by a minus 2 cos x divided by sin x. The problem says upon x, so divided by x also. Now let's do one thing. Divide by x multiplied by x. We know that limit x tends to 0 per sin x upon x is 1, and 1 minus cos x upon x is square. When x is approaching to 0, this is half. So can you write this as 1 by 2 limit x tends to 0 a minus 2 cos x? Now if you take x as 0, this gives you a minus 2. So we have a minus 2 upon 2. But boss, limit की value given है, which is equal to half. Cancellation. So this gives you a minus 2 is equal to 1, which implies a is equal to 3. So we got the value of a, right? So what is your f of x now? So if you recall your f of x was, check the form. It was 1 minus cos x multiplied by a minus 2 cos x divided by sin x, right? This was your f of x. Now let's take a as 3. So it becomes 1 minus cos x multiplied by 3 minus 2 cos x, and this divided by sin x. If you look at the integration part, the integration was pi by 3 to pi by 2, and the problem was 1 upon f of x. So this becomes pi by 3 to pi by 2. 1 upon becomes sin x upon this is 1 minus cos x, which is multiplied by 3 minus 2 cos x. अब ये तो simple form में है यार. Direct substitution will work because I can take cos x as t. Then minus sin x dx becomes dt. So what about the limits? So your integration becomes, when you take x as pi by 3, cos pi by 3, half. When you take x as pi by 2, then it becomes 0. Minus, I will replace this sin x dx by minus dt. So dt, minus sign is out, and it becomes 1 minus t upon 3 minus 2t. And now we can apply partial fraction. Right? Or you can write even this as 0 to half this dt upon 1 minus t, and this is 3 minus 2t. So if I use partial fraction, it is 0 to half. This is 1 upon 1 minus 2, and this is minus 2 upon 3 minus 2t. You can cross check. It will definitely work because if you take the LCM, it gives you 3 minus 2t and minus ka 2 plus 2t, that gives you, okay, perfect. I think your problem is over. You can integrate this. First integration will be ln of 1 minus t with negative sign. Second will be, this is ln of 3 minus 2t with negative sign, so it becomes plus. Okay, from 0 to half, or even you can write this as ln of 3 minus 2t minus ln of 1 minus t from 0 to half, or this can be written as ln of 3 minus 2t upon 1 minus t from 0 to half. So if you take the upper limit, so it gives you 3 minus, so if you apply the upper limit, it gives you ln of 3 minus 1, that is 2 divided by 1 minus 1 by 2. And if you take the lower limit, it gives you ln 3. So it gives you ln of 4 by 3. If you remember, the problem was this integration is of the form ln of p by q, where p and q are relatively prime positive integers. You can check. This satisfies all conditions. That's why p is equal to 4, q is equal to 3. The problem was p plus q, so p plus q becomes 7. This is the answer.